miss Karine?
Yes, now it's okay.
Oh, perfect.
The recording is beginning.
Thank you. And do we miss many attendees, or could we start?
There is 26 participants.
And how many?
27. So I think that it's about half of participants.
Okay, so perhaps I will wait 5 minutes and
Yes.
after we start.
I
Perfect.
think 5 minutes it will be okay.
Thank you. Okay, so now I think it's time to start. We have wait 5 minutes more and it's time. So thank you all for attending this meeting and this training workshop. We are pleased to welcome you for the 3 days training. And just remind that this training workshop aims to present you the knowledge gained from our research project, so-called EDC-WFD, a project whose objective is to develop reliable and harmonized measurements method for estrogens, which are key endocrine disrupting chemicals, to comply with Water Framework Directive requirements. And its aim is really to accelerate the transfer of the most promising measurements methods that we have developed and the methodologies also to interested parties, you as laboratories, PT provider, researchers. And the training will cover all the aspects of measurement from the sampling to the final method validation, and will address both mass spectrometry-based method as well as incoming effect-based methods, so-called also bioessay. So its objective is really to share information and to have a global improvement of knowledge and the sharing of experience. So please do not hesitate to contribute to this workshop by sharing your feedback, experience, and alternative strategies and successful strategies that you have developed in your laboratories. It really, we are really expecting fruitful exchange during these 3 days of meeting. So here we are the first day, so we will have general information about our project and its objective, and we will briefly summarize the issues and challenges related to estrogen analysis in relation to the WFD. We will have feedback about the issue of the sampling and especially the stability of targeted analyte between the sampling time to the beginning of the analysis. And we will address all the issues dealing with the quantification and how to label the quantification process and all the sample prep. And for today, it will be enough. We will push you tomorrow morning with a mass spectrometry-based method and all the achievement we have had in the project dealing with this specific aspect. And we will mainly focus on all the issue of the validation and to demonstrate the strengths of the work we have underpinned during these projects. And we will have concluding remark, and then we will discuss with you with the next step, which is the organization of an interlaboratory comparison. And we really hope that some of you will be interested to take part to this interlaboratory comparison. And we will be pleased to answer to your question on these specific topics. And on the last day, on Friday, we will have a specific session dealing with focusing on effect-based method. And once again, we will answer and share with you the feedback experience we have achieved in the project and share this experience with you. And especially some of you, we have also trained and strongly advanced in this field, because here there's really a need to improve our global communities in these specific items. And I do not know if some of you have a question or remark or comment to make on this 3-day session. I just would like to express to you how we'll proceed. We will ask you to put question in the chat, and we will have specific time in all the session to take time to discuss and if necessary, give you the floor to express your feedback and ask question. But please, the chat will be the main way to exchange. And some people in the organization committee will give you the floor if necessary. I do not know, and because I do not see if there's question of comments, so please, Karine, do not hesitate to take the floor to help me in that, yes, activities.
At this time, no question.
Okay, thank you. So if there's no more question, I suggest that we start by presenting to you what is EURAMED. So EURAMED is the European Association of National Metrology Institute, is the gateway to Europe's integrated metrology infrastructure. It aims to facilitate access to European measurements expertise and underpins the delivery of globally competitive, high-impact metrology. It ensures Europe maintain its global reputation for excellence in measurement science, and it raises awareness of the value of measurements by demonstrating the impact of metrology on society's grand challenges. So this is really the global infrastructure where we are dealing with in this project. So this European association, so-called EURAMED, has more than 38 European NMI, so National Metrology Institute members, and 21 and more than 78 designated institutes, which is a global critical masses of more than 5,000 metrologists involved. And if you are interested to learn more about Euromet, please do not hesitate to have a look to this website, and you will learn more about all the metrology community within Europe and all the activities we are underpinning. For more than now 20 years, Euromet is routinely promoting research and as supporting research and innovation projects. So this project is supported by Ampere project. So Ampere research program is about improving measurements to drive innovation and competitiveness in Europe. It enables European Metrology Institute, industrial organization, and academia to collaborate on joint research projects. It is implemented by Euromet and based on Article 188 of the Lisbon Treaty. And it's jointly funded by both Ampere participating countries and the European Union, and has an overall budget of more than 600 million euros. And it's now our project is supported by this Ampere funding. So the big challenge and problem that are addressing by this program is to increase to answer to the increasing demands on metrology infrastructure alongside static or reducing national budgets. So it requires strategically planned metrology research and to ensure delivery of metrology capabilities and services to meet European needs. So we are addressing in this program high-level objective, European growth and job, respond to societal challenges, and especially all the need of regulation and to support competitiveness, and also support European directive. And we are really in that objective in this project. And it's also to create an integrated European research area. It has specific objective to boost industrial uptake of metrology research, supporting development of new and improved products and services, improve standardization and regulation, and underpin a current, sustainable, and integrated European metrology landscape. Its operational objectives are to develop common research agenda, support European collaboration, fund projects that support innovation, regulation, and societal challenges, help and sustain capacity building across Europe, and have an efficient and effective program management. So Ampere objectives are really to boost industrial uptake and improve standardization. And we have at least 400 million euros of European turnover from new or significantly improved products and services that can be attributed to these research activities. And at least 60% of CEN, CENELEC, ISO, and EC technical committees and equivalent standardization bodies with potential to benefit directly from Ampere projects to engage within the program. And the project has yet delivered 17 published and 103 draft standards. So it also has objective to underpin a current, sustainable, and integrated European metrology landscape to fully exploit all the EU potential, and maintaining a level of at least 50% of dedicated national metrology research investments in Europe being coordinated or influenced via the program, and the level has been achieved, and all European NMIs and their designated institute to interact within this program. And European leadership is at least 20% of international metrology committees, which means that Europe has strongly an influence on the worldwide community of metrology. It has now been closed and has been replaced by a new program, and as Horizon Europe program, which is called European Partnership of Metrology. This partnership will bring together the measurement science community and all the stakeholders to deliver on global challenges, including health and climate, support the European Green Deal, and underpin innovation in industry through collaborative research. This EPM aims to support accelerating the transition towards a green, climate neutral and digital Europe, as well as strengthening the resilience, competitiveness and economic growth of all European industry. And this partnership are also a key implementation tool of the European Commission Horizon Europe, an ambitious research and innovation program running from 2021 to 2027. So the EPM is still co-funded by the member states and the European Union. I think it is a unique one functioning like that, and have an expected budget of over 650 million euros. It's expected to have impact is manifold, and it will support a wide range of policies, commerce and advancements of key European challenges. It will build the programs achieved under this program and aims to break new ground by contributing to the development of self-sustaining coordinated metrology infrastructure, so-called EMN, with the capability to continue joint research and innovation after this 2030 deadline. And if you want to learn more about this European partnership, and if you want to take part to the research that is underpinning or that will be underpinned in the next coming year, please do not hesitate to have a look on the website, and we will be pleased to develop new research program and research project with you in the near future to tackle all the issue linked to, and it's not a few words to say that, all the issue linked to the WFD implementation that will come in the next future. So now coming back to our project. So just a few words about our consortium. So we are 8 partners coming from 6 different European countries. The project involves 5 NMI DIs, 1 working outside of its designation, 1 academic research laboratory, and 1 research institute. Our consortium brings together scientific excellence in research and dealing with ultra-trace analysis and measurements of micropollutants in the environment. And we have a balance of expertise between our different institutes, dealing with development and certification of reference material, proficiency tests and interlaboratory comparison design, method development and validation, and standardization. The project starts in September 2019 and for an initial duration of 36 months, but we have an amendment of 6 months more to face to the issue of the COVID-19. And we have an overall budget of 800 kilo euros to perform all this research. But before to go more in depth, I would like to show you that institute is, we are all involved as institute, but we are teams and there are people who are working actively for more than 3 years in a very difficult condition to face and to deliver what was expected from us. And I would like to show you who we are. And just before to start, all the people you see there are behind their camera. The camera switch off, but we are real people. And it's a pity that's not been possible for us to organize this meeting in real as it was initially anticipated. But yes, just to show you that we are real people investigated in delivering this training. And we are real people. Coming back to the science. So this project aims to address the standardization lack for harmonized measurements method of estrogens in well water. It's aimed to ensure that measurements of estrogen are traceable, well-defined, meet the requirement of the WFD, and thus are comparable across Europe and also, of course, if possible, worldwide. So here, this project is really focusing on delivering to standardization to ensure that we have a chief stakeholder in the person of Ulrich Burscher, who is the chairman of the CEN-TC 230 dealing with water quality issue in Europe. And we are strongly interacted with all the standardization body within Europe, especially the Dean, who is the secretary of the CEN-TC 230 committee. And we are supporting by AFNOR, so the French standardization body, to develop the future standard we have promised to deliver. The general context of this project, a few brief picture, we will go in depth later and we will come back to that in more detail. So all of you know estrogens. They are a group of chemicals of similar structure, mainly responsible for female sexual development and reproduction issue. In water ecosystems, they could be considered pseudo-ubiquitous and occur at ultra-trace level, far below nanogram per liter in most cases, but in sometimes tens nanogram liter, and this is the level at which they can have adverse effects in natural species, and they are considered to be a threat for biodiversity. They were included in the first watch list of the Water Framework Directive, and now they are under review to become priority substances of the WFD. At this stage and at the beginning of the project, there were no EN or ISO standard for MS-based methods currently available or in progress. Accredited testing laboratories face many issues to address the requirements in terms of sensitivities, LOQ, to enable a reliable monitoring of estrogen at a relevant level. Many of us were developing and validating in-house methods according to internal criteria. There's many metrological endpoints that have been highlighted of particular importance, dealing with the recognition and acceptation of effect-based methods if they have to be used in regulatory context, and there's the lack and absence of reference material and ad hoc proficiency tests. This is the picture at the beginning of the project. So just to summarize once again, our aim is really to develop reliable and harmonized measurements method for estrogens to comply with the WFD directive requirements, and to disseminate to CEN or ISO all the necessary input to draft and deliver soon as possible the standards that are missing to have, I would say, reliable and effective measurements of estrogens as necessary to comply with the regulation. So the general objective of this project is to develop traceable measurements method for endocrine disrupting chemicals, focusing on the 3 estrogen of the watch list, and also introducing 17 alpha estradiol and estriol to demonstrate the reliability of the developed method. And here our objectives are really to support the requirements of the directive 230. Please, could you close your microphone if you do not speak, please? Just for all the audience to be in capabilities to hear. Thank you. So here our objectives are to meet the requirements of the Directive 230 and also those from the Directive QAQC, and to improve the comparability and compatibility of measurements to this of all the results within Europe. Specific and more detailed objective: optimize and validate traceable aqueous reference mass spectrometry-based method for the analysis of the selected estrogen, and in whole water samples and at environmental quality standard level. And our method have to have limit of quantification not exceeding 30% of the EQS and uncertainty, expanded uncertainty of at least 50% of this EQS. Our objective was also to develop production method for aqueous reference material, which are as close as possible to real water samples with proven homogeneity and short-term and long-term stability, improve the comparability of estrogen measurement with selected effect-based methods in whole water measurements at EQS levels, and method will have been correctly calibrated and information uncertainty will be provided. And our objective was also to organize and perform an inter-laboratory comparison to demonstrate that the performance of the developed method using the reference material we have developed for the selected set of estrogen substances and lists to contribute to the work of the European and international standardization organization. Here is the view of what we have done, really focusing on this scientific and methodologic point of view. So we have worked and optimized and worked on storage condition. We have work and investigate different sample prep approaches, liquid extraction, SPDISC, SP cartridge, online SPE, different way of purification of the samples. And we have also investigated different type of detection approach. So those were based in mass-based methods. So we have investigated liquid phase chromatography affinited to both tandem MS and high resolution MS. And with this technique, we have also investigated the potencies of direct injection. And we have also investigated GC, gas chromatography, affinited to both, also tandem mass spectrometry and high resolution mass spectrometry. And for the MS-based method, we have implemented isotope dilution. And in parallel, we have also investigated a selected set of bioessays, Calux, as an and complementary approach. We have investigated the comparability of the method, and we have also investigated the equivalency of the results. And with this, I close this overview of the context and our project. And if you have, I do not know, please, Karin, once again, I ask you for support if there's common question in the chat, or if someone would like to ask question.
At the moment, we have no question.
I really hope that we will share a lot of discussion during this meeting. Otherwise, it will be really it would be a bit pity, I would say.
Sophie, one question from Salvatore Barreca. Can direct ingestion used for quantification of well ether sample determination?
So I will not spoil the next presentation from my colleague Christian Piecota. So if you agree, we will keep this question for later, where we will discuss on how the issue dealing with the sample prep and so on. And tomorrow we will also discuss this point with the issue of the limit of quantification, and the issue also to answer how could we manage the issue of whole water measurement. So if you agree, we will keep this question for later. I will not spoil my colleagues' talks. Are you still? No, I think that you do not see really now. Do you see my screen correctly? Yes, you see it?
It's double screen.
Double screen,
yeah.
So it's a problem. How should I manage? I'm very sorry.
There is a cross on the right.
This one, I'm not sure. I will close.
Yes.
I think I will. I will try to share my screen once again. So I can't change. I'm very sorry for that. It was working correctly just before. Yes, now it will be okay. Is it okay now?
Yes, perfectly.
Yes, thank you.
Okay.
I'm sorry. So now let's go back to some generalities around estrogen and all the issue. As it is an open training, perhaps for some of you it will be evidence, but we will make a brief overview. And sorry if for some of you it's evidence. So some generalities on estrogen. So we will start by discussing around the biochemical cycle, fate, and occurrence of all these substances. But before to start, let's go back to the basics. So physical-chemical properties of this selected set of substances. So just to remind you that estrogens are typically both low water solubility and mid-log KW. So it means that they are hydrophobic and have high potential to bind to sediment and suspended particulate matter. And with respect to these biochemical properties, we know that the main phenomena that will support and lead to the attenuation and dispersion and dissipation in the field are photolysis, biodegradation, and sorption. And it is really important to take in mind that they are definitely not polar compounds, and they have real capabilities to sorb to organic or SPM in natural ecosystems. So just an overview of the bibliography dealing with sorption. So we have evidence that they have really strong interaction between those substances and the suspended solid. So if I just catch some bibliographic reference. So the study from Yuihan Hall and Brett and Hall that observed that in one day, no less than 80% of molecules could, especially ethinyl estradiol, can sorb to suspended solid and reach steady state within 10 days. Estrogen can also sorb to humic acid in water and have, in the presence of saline compounds, such as those we can face in marine water and also in some estuarine water, we have induced flocculation and aggregation. We can promote the sorption processes. Estrogen sorption capability is also positively related to total organic carbon content, since the sorption occurs through hydrogen bonding reaction between organic carbon and estrogen compounds. And there is also evidence that strong sorption competition effects between one estrogen compound and other estrogens or hydrophobic compounds for sorption sites have been demonstrated, and the competition is most significant when the concentration of the primary sorbate is low and the concentration of the competitive sorbate is high. Isomer-specific sorption of estrogen is dominating by H bonding and aromatic interaction, which 17 beta estradiol sorption was preferential than 70 alpha estradiol 1, and the orientation of the hydroxy group and the C18 position of the D-ring plane may favor the sorption of 17 beta estradiol, while that of 17 alpha is outside the plane. And the sorption process of estrogen is associated with organic compounds, colloids, composition of clay minerals, specific surface area, cation exchange capabilities, and pH value in the environment. It means that it is very difficult to predict, and the issue of whole water measurement as necessary to answer to the WSD is really important. Photodegradation phenomena are also important, and estrogen, and especially estradiol and ethinylestradiol in aquatic environment are also susceptible to breakdown by photocatalysis and photolysis phenomena, and the extent of degradation by photolysis and photocatalysis depends upon estrogen chemical structure. The photolysis process of estrogen is affected by humic substances under simulated sunlight, and ethinylestradiol degradation has been studied in a lake site in the US, and under aerobic condition, half-life was estimated as 150 days, but under natural sunlight, photodegradation accounted for a much shorter half-life of no less than 23 hours. Biodegradation are also important phenomena for all the estrogens, and it is really an important topic with respect to the stability of the substances that we have to address in our measurement process. So here it's a picture coming from a review from Adil and Hal, showing all the different mechanisms that sustain this propagation phenomena. They are both specific in aerobic and anaerobic condition, and it's clear that estradiol and estriol lie on interconnecting metabolic pathway. Microorganisms living in aerobic and anaerobic condition can convert one estrogen to another, and even ethinylestradiol can be converted to estradiol. So it is really important to take all that things in consideration, and it is also a good justification to include estriol and alpha estradiol in the global pictures to target good estrogen measurements. And last but not least, metabolization is also an important information to consider when dealing with estrogen measurement. So just a reminder, metabolization is a way that is implemented to allow the excretion by humans and animals in complex mixture of free and conjugated form. It is a way for the organism to purify itself and to excrete and to allow the excretion of natural I will say hormones, but also xenobiotics. It is a two-phase process. The first process is really supported by oxidation, hydroxylation, and reduction process. And the second phase is linked to a conjugation. So it means that you add some organic group, glucuronide, sulfo, N-acetyl, or glutathione S to make the pollutants more polar and to allow the excretion through urine. So it is really an excretion process. So it leads to important interconvection of the natural substances. And here it's an example with ethinylestradiol, so to show you that it is an important process, and only a few part of the, I would say, a parent compound is excreted in its initial form, and in fact the major substances that are excreted are in fact conjugated forms of the natural substances. So it's once again has really to be considered in the development and when thinking the design of your development to have, I would say, reliable measurements of estrogens. So here, to see how it is complex, you have here a picture of all the metabolization process of the estrogens family to show you how it is complex, and that it leads to chronic release to the environment of very complex mixture of natural and conjugated forms. And conjugation is something which is reversible and could lead to the formation of free conjugated forms or new transformation products. So it is really, once again, something that you have to consider when developing and measuring hormones in the environment. So to summarize here, just a picture, and it's, I would say, a classical picture summarizing all the fate and occurrence of these substances. So they can be natural or synthetic. They can be released through various uses as pharmaceuticals, or also as natural release of all mammals, so us humans, but also all livestock. And we can also have significant contribution of the industry and significant contribution of the agriculture, especially in the country where spreading of sludge is allowed, and it is especially the case in France. And you can have also release to the different ecosystem, especially to the major entrance to the environment are wastewater treatment plants effluents, but livestock and agriculture release should not be underestimated in this overall process. So even if wastewater treatment plants are effective to significantly remove and have a decrease of the content of estrogens within the process, you have nevertheless chronic release to the environment. And considering the physical-chemical properties of this substance, they have the capabilities to really disseminate the different compartments of the environments, and that leads to, in fact, chronic state of contamination to the environment. The point is that the level of concentration that are measuring in the natural environments are susceptible to be responsible of effects that can be observed and different effects that can be observed in the natural content. Here, an overview concentration that has been measured worldwide, both in effluents and second in natural body. So here you have the sum, and you have both different kind of measurements, but here just to show you that the level is significant and can be comprised between below nanogram per liter to more than 10 nanogram per liter in Europe, but we see that in other countries the levels could be highest, but it's definitely linked to the level of advancements of the wastewater treatment plants you are facing. And in natural water body, here again, significant measurements of estrogens worldwide. And here you have the European picture, which is not so in line, which is in line with all the picture of North America, but we have also, of course, a country where the part of the world where the level are much more higher, but it's clearly linked to the level of sanitation and the efficiency also of the process of the wastewater treatment plant process. If we have a focus on I would say more in depth the different estrogens. Here we see that the picture is we have a huge amount of the different form in wastewater treatment plants, and how to say the level are once again not are significant with respect to the risks. And here in the water body, the same picture. we cannot underestimate the risks of estrogens in the natural environments. So we have really water bodies at risk. And if we have a focus on Europa, and here it's time to show you the result from the watch list monitoring that was underpinned in now between 2017, 2019 to support the prioritization process. Here you have the results of the different country and the level of measurements of oestrone, 17-beta estradiol and 17-alpha estradiol. And here you have the PNEC that were considered at this time. It's not a new one, but at this time to evaluate the risks linked to these different estrogens in European water body. And you can see that we have really risks, because we see that we have in many countries measurements that are up to this PNEC, so meaning that we cannot underestimate the risk linked to this to these substances. And here you have the table summarizing the mean, medium, max, and p different percentile of these different substances. So we can see we can really have high level, and that the median value are really close to the PNEC once again. And if we go back to metrology and to measurements capabilities, if you have the picture summarizing the range of a limit of quantification of the method that were implemented to support this watch list process, and with respect to the PNECs that were in place at the time. And we see that in many countries, and we are not, in fact, we are not in capabilities to really have an effective and relevant monitoring of these substances, because the LOQ are up to this PNEC, so you cannot really have underpin risk assessments in that condition. So it legitimates all the work we are all underpinning since that time to improve the measurement capabilities of these substances. And here really the main challenges was on ethinyl estradiol, but there are still challenges for all the other estrogens. Going back now to the regulatory context, so you all know the directive, the Water Framework Directive. Sorry. Please, could you close your microphone if you do not speak? Thank you. So the directive, the Water Framework Directive, establishing a framework for the community action in the field of water policy with a precise timetable, and to have within 12-15 the deadline for getting all European waters in good condition. We all now are aware that we failed to achieve this goal. So it is completed by a daughter directive, especially the directive 218, 105 EC, that laid down environmental quality standards for all the priority substances and certain other pollutants. The directive, so-called QAQC, that laid down technical specification for chemical analysis and monitoring of water status to allow comparable results of all over Europe. And the directive 230 that introduced the watch list process monitoring mechanism in order to collate high-quality union-wide monitoring data for the purpose of supporting future prioritization exercise. We will know also the Commission implementing decision 215/495, establishing the first watch list and introducing estrogens as key priority substances for this first watch list substances monitoring scheme. And this has been completed by the Commission decision 218, sorry, that lead to the maintaining of these estrogens in the watch list process because of insufficient data quality. And now we have finalized this watch list process. The Commission and the GRC is working, and the working group chemicals is working actively to evaluate the potencies of these substances to become priority substances, priority pollutants in to support the revision of the priority substances list of the watch list. It is under process. It should be finalized by the end of 2022. And the important information that has to be considered is that the PNEC now has to become environmental quality standard, and there's been a huge work on the PIN in the working group chemicals specific working group experts have proposed revised EQS. And the bad news is that the level to be target has been decreased. And here they are summarized here. So here it is a proposed EQS for inland water. So you see here they are drastically decreased, especially for estradiol and estrone. And they have also been decreased by a factor of close to 3 for 17-alpha ethinyl estradiol. And here, the objective for salted water, and I let you discover that we are 10 times lower than for inland water. So here the challenge for salted water are more than ever there. So the decision to update the list of priority substances is under the table. So we have a new wide comprehensive assessment of the watchlist compounds, estrogens, is not feasible in the current situation. And there has been requirements and to introduce in vitro effect-based method together with respective substance-specific effect-based trigger values as a tool to discriminate between a sufficient and insufficient chemical status and defined by subjective EQS for estrogen with sensitivities and specificities near 90%. And this is in fact extracts from the dossier of these substances. And just to inform you that the project has been identified as significant to support this prioritization process of the estrogens as possibly delivering significant input to improve the measurements of estrogens either by MS-based method or EBM methods. Yes, so really in vitro EBM are really under the focus, and we will come back to this in detail tomorrow morning with, Friday morning with a specific session that will be focusing on this EBM. So I will not spoil this session, but please all keep in mind that they are the future, and we should all be prepared to implement EBM measurements in the near future. So I would like to make a focus on the directive QAQC, which is really a strong focus for us. So it establishes minimum performance criteria for methods of analysis to be applied by member states when monitoring water status, sediment, and biota, as well as rules for demonstrating the quality of analytical results. In its Article 2, limit of quantification is defined by means of stated multiple of the limit of detection at a concentration of the determinants that can reasonably be determined with an acceptable level of accuracy. And in metrology, here we are strictly speaking about trueness. and precision. The limit of quantification can be calculated using an appropriate standard of sample and be obtained from the lowest calibration point of the calibration curve, excluding the blank. And uncertainty of measurements are defined as non-negative parameter characterizing the dispersion of the quantity values being attributed to a measurement based on the information used. So now we have defined concept. So now we go to the requirements. So all method of analysis should be validated and documented in accordance with ISO 17025 or an equivalent standard accepted at international level. And the minimum performance criteria for methods of analysis are the following, and you all know them by heart, right? Sure. We should demonstrate uncertainty of performance of 50% or below estimated at the EQS, and limit of quantification equal or below a value of 30% of the relevant EQS. And in the absence of relevant EQS for a given parameter, or in the absence of method of analysis meeting the minimum performance criteria, monitoring is carried out using best available techniques, not entailing excessive costs. In its Article 6, we have also specific requirements dealing with quality assurance and control. So once again, all laboratories and parties contracted by laboratories should follow ISO 17025 or an equivalent, and laboratories or parties contracted by laboratories should demonstrate their competencies in analyzing relevant physicochemical or chemical measurements by participating in proficiency testing programs at levels of concentration that are representative of chemical monitoring program, and analysis of available reference material that are representative of collected sample at plus appropriate level of concentration should be underpinned. And I have to say that there's no clear requirements on traceability to SI, but that does not mean that it should not be considered, because it is requirements of the 17025. And last but not least, just a few information just to inform that the drinking water directive has been revised, and to answer to the requirements of the WHO organization, endocrine disruptor has been introduced in this new version of the drinking water, and the 17 beta estradiol has been introduced as first watch list substances for the drinking water, and the level that should be achieved has been set at a limit of quantification of 1 nanogram per liter. So there's also issue and challenges that could be addressed through the project we are, through the work we have underpinned within this project to address also the issue of the drinking water directive. And with that, I have finished this big overview of the estrogens, key concepts, key challenges, key regulatory requirements, and there's time for question if some of you have some questions.
Sophie, we have one question from Eric Chauverheide. Traceability to ESI is included in ISO 17025. Sorry for French.
Yes. Yes, it is mandatory to demonstrate the traceability to SI of measurements when it is possible. So it is really important. Does the question is, what is traceability to SI? If it's the case, we will have a specific items tomorrow to have this information to you because as metrologists, it is our mission to guarantee this traceability to SI of all measurements. And we will have a specific point tomorrow morning to address this issue. Or perhaps I did not catch the question.
In fact, Eric said, no, it was not a question, it's a fact.
Yes, yes. So I agree, I strongly agree with you. It's stated in the ISO, but it's just in some regulation in our directive that are targeting other field. It is also strictly it is a requirement within the directive to have the traceability to SI of measurements. So it's strongly put in evidence in the directive. In our case, it's not the case. It is only supported by the requirements of the to be ISO compatible with ISO 7005 requirements. It was just an information. But yes, I strongly agree with you. It is not. It is mandatory.
There is one more question from Salvatore Barreca.
Yes.
By considering that LUQ is 30% and by considering EQS value for UU2 0.017 nanogram per liter for UUU is required or LUQ at 0.005 nanogram per liter?
Yes. Or 0.006. Yes, this is the requirements, the new requirements. At this stage of knowledge about the prioritization process, it is the last feedback from the chair. So the chair is an official body that advise and supports all the regulation. This is their positioning. But now it has not been endorsed and the final decision has not been taken, but it is now the EQS that are in the table. But they are not been formally agreed, and we have to wait until the end of this year to have the final conclusion. But this is the revised level we have to consider if we want to be compliant with the requirements.
At this time, we have no more questions or remarks.
So sorry, I raised my hand because I have issues of writing on the chat. I'm working on my mobile phone and it's always translating things to German. And it's okay if I put my questions by audio?
Yes.
Yeah, thank you. Yeah, thank you very much for showing this complex metabolism of the estrogens. Just to be sure, it is not thought that kind of a pre-processing is taking place, for example, a deconjugation of possible conjugates present in a sample to assess an overall estrogenic potential. So we just measure E1, E2, and so on as it is in the sample and do no deconjugation or something like this.
Yes, so we will come back to this issue later because yes, the requirements is to measure free form of estrogen. But the point is that to be sure that during the analytical process, you will not, by the process of measurement, have a degradation of possible conjugated form that are in the sample that could have, in fact, and have as consequence a bias in the measurement you will underpin. So we have specifically addressed this issue in the projects to demonstrate that our protocols do not lead to degradation of conjugated form to free form. Doing so, we assume that we really focus and strictly focus on the free form of estrogen without any bias. But we will come back in details in the next presentation of my colleague in this specific issue.
Thank you.
You're welcome. So if there is no more question, we will go to the next point and we will discuss on sampling and stability. But I need to share my screen. I'm very sorry. I have some problems with my computer. Do you see my screen in full screen?
Yes, Sophie, it's okay.
Thank you. So now let's go more in depth in the measurements process, and every measurements process start from the sampling, because if the sampling is not performed in a good way, the measurements at the end will not be accurate and will be of, I would say, less relevance. So general rules. Sampling should comply with general principle of ISO 567 guidances. It should implement general principle for ultra-trace analysis, and we have not identified within the project specific risk of contamination in the field, within the and in the field, when we say field, environment, operator, and so on. So at our level, we did not identify any risks of contamination. Our recommendation will be to use glass bottle, and to prevent from photo degradation, use amber or green bottles, or if it's clear one, to protect with alumina foils and so on. To avoid intermediate material, to prevent from losses due to sorption and from risk of cross-contamination, especially if it's plastic containers and things like that. That could be tremendous, especially when focusing on the lowest level of concentration. Cleaning procedure should be implemented. Calcination of glassware is really something we could recommend, but if not possible, rinsing with solvents and water is definitively necessary. We recommend also to avoid plastics, and clearly, and it's not an option if you want to tackle EBM method, because otherwise you will have possibly other xenobiotics that will have effects as estrogens, and you will have problems with measurement. So we recommend to avoid plastics. Here, just a picture. It's not coming from results from the project, but from bibliographic results showing the issue of sorption with estrogens depending on the type of container and material you are using. And you can see that you have significant losses depending on the type of containers and type of you are using. So this is why we strongly recommend to have very specific attention to this point. And we have minimum losses with glass containers and materials. This is why we strongly recommend it for both prevent losses and also because you can have more advanced cleaning procedure to avoid, I would say, cross-contamination. This is the point for sampling. Do you have question on sampling or perhaps other experience to share?
There is no question or remarks.
Okay, so if not, we pursue. So now we have nice samples and we are facing to the big issue, the stability of the analyte between the sample and the arrival to the laboratory and the start of all the analytical process. So we have here again, make some tests and developments in the project. And it's we will share some of these results with you. So just a reminder, the main drivers from the absorption and for this issue are nicely summarized in this picture coming from a publication from Sophie Mopela. So you can have degradation, you can have adsorption, you can have formation of complex, and you can have also cross-contamination once again. So we have overview of all the publications that have been addressing this issue, and not all of them are in agreement because we have different methodological strategy, we have different acceptance criteria, and sometimes we are missing information that enable to enable the, I would say, good consideration of the results that has been delivered by those works. So it was difficult to avoid some new tests within the project. So this is what we have done. So the test has been underpinned following ISO Guide 35, which is a specific guidance dealing with the development and characterization of reference material, especially focused on homogeneity and stability study. And we have also considered the new standard that has been recently published, and that ISO technical specification 5.6.6.7.28, focusing on guidelines for the validation of the preservation time of water sample, and that promote the recommendation on maximum acceptable delay before analysis. And all these results, you can find them in some deliverables of the projects that could be found in the website of our projects. But here, an overview of these results. So we have made a different test with an increasing level of complexity. So we have made some tests on considering the 5 estrogen targeting in the project. We have made tests in synthetic real water matrix based on Evian water, DOC level at 7 milligrams per liter, and pH at 7.3 without SPM. It was the first level of complexity. We have a concentration level of 10 nanograms per liter. All the content are glassware, and they are protected from sunlight. So we have made different tests at different storage condition, so 4 degrees and room temperature, and we have made some tests with different preservation condition known, 0.1% methanol and 0.1% ascorbic acid for an overall duration of 14 days, and we have time lapse of course we have D0, of course, but we have also D1, D2, D3, D4, D5, D14. We have made tests in isochronous conditions, which means that all the experimental study of reference material stability exposed to different storage conditions and time are measured in a short period of time. It means that you are in a repeatability condition to underpin all the measurements. Doing so, you have the potential to really evaluate at the best the stability and the homogeneity without taking into consideration the drift or your instrument and so on. So it is the best way to perform stability studies. And we have observed the total instability at room temperature, and we have stability at 4 degrees up to 14 days in this specific condition. And with ascorbic acid, we have observed an increase of the standard deviation of the measurement, so a decrease of the performance of the methods in these specific conditions. We have also then made a second stability studies with more complex matrix. And in fact, in the matrix, we have included solid particulate matter at a level of 500 milligrams per liter. And our conclusion are the following: without stabilization reagent or with 1% methanol, we do not see any significant trend with regard to the degradation or loss of the during the storage time. And with ascorbic acid in this second study, we also observed the same trends with a decrease of the performance of the method in strong relationship with this ascorbic acid content. And then we also make a third stability study, and here we have introduced bacteria, model bacteria, to have the impact of, I would say, the physical process and the biological one. And here again, we have an impact. We have observed an impact of the microbial activity, but not significant in our condition. But we have to consider that it is model samples, and we have chosen model samples. And why? Because the result, all the experiments has been made in different laboratories. So to overpass the issue of the impact of the natural water samples that could not be shared within Europe in satisfactory condition, we have chosen to make all the tests in a representative synthetic real water matrix. But doing so, we can compare the results between the different members of the project. So concerning stability, here, this is a recommendation we would like to deliver, and on the basis of our feedback. Material in contact with water sample should be cleaned cautiously. Glassware should be preferred to any other type of material if LOQ below 0.1 nanogram per liter targeted to minimize the risk of absorption and contamination and possibly interferences. The storage of samples, complex samples at 4 degrees is okay for 7 days if low complex matrix. For complex matrix, storage time should be shortened, and addition of 1% methanol is recommended to avoid biodegradation. And the storage of at -20 degrees is okay because we have demonstrated that all the substances are stable, especially are not degraded by freezing, defreezing process, but could be at risk of clogging if SPE cartridge are implemented later in the process. And we have observed also some impact on the matrix effects that were increased when we have this storage at -20 degrees. This is why we do not recommend it at first, but it could be an alternative if you cannot be sure of respecting short time between the sampling and the start of the analytical process. And once again, we do not recommend container a plastic container if you have to underpin such kind of measurements. This is the conclusion of this step, and I do not know if you have question, remarks.
Sophie, we have a first question from Sibyl Mallet about storage of a glass bottle.
Yeah.
Glass bottles tend to break when frozen and transported. Do you have a solution for this problem?
Yes, we have bad experience in the project on that. Yes, clearly. So the solution. So for the transport, of course, you have rules to be taken in mind to have everything well in the device that is used, and you have to use some specific containers to prevent from breaking and things like that. But for the freezing process, our experience was not to fill the bottle in total, but to have half of the bottle filled only to prevent from breaking, and to be very cautious when you are defreezing, letting them defreezing, not putting them in hot water and so on, just letting the defreezing process going slowly at the beginning to prevent from this breaking. One other recommendation is to be very, very cautious when if you reuse bottle, and especially if you are making a calcination, because it's clear that if you run more than one cycle of calcination, and if you repeat process, of course, the glassware will be become fragile and you will increase the risks. But one of our experience is really not to fill the bottle in total, but to fill them at half.
Two questions from Eric Cheverhead. Have you tested thiosulfate needed to dechlorinated drinking water? This is the first question. And the second one, why not using the conventional phenol stabilization condition through acidification of the sample that should help extraction?
Yes, so first question. So yes, we have made some tests with thiosulfate, because you will see it later tomorrow, but I do not want to spoil, but some of the partners are making the validation also on drinking or tap water. So doing so, we have introduced this thiosulfate, and we do not observe any issue when introducing thiosulfate as recommended as in all the other standards. So yes, we have tested it and without any trouble in the project. And concerning the second question, yes, we have made an overview of the bibliography, and at one moment we have been obliged to select some critical preservation condition. We have some background from some partners that show that when implementing some acidification, you can favor some, I would say, degradation phenomena for some substances and not for the others. This is also the reason why we did not select it at first. And also one other, I would say, information is many of our methods do not need an adjustment of the pH, because we do not need them later in the process. So this is also the reason why we did not implement it earlier in the process of measurements. So I do not know if I answer correctly to your question. We have background information that acidification could lead to preferential way of degradation of some of the targeted estrogens, and we do not need necessarily in many of our methods the adjustment of pH to make the extraction. But did I answer to the question?
I think it's okay, because Eric said, okay, thanks.
Okay, perfect.
There is another question from Marianne Robinson. What about the bottle caps or liner? What material do you recommend?
So yes, it's true that you can have also, so we have specific cleaning of the bottling of the cap, also with solvents and water to prevent from contamination. And it's clear that putting alumina foil to separate and prevent the contact between the sample and the cap is also recommended. Did I answer the question?
Yes, thanks.
Perfect.
We have a hand from Sebastian Buchmender.
Yes.
Yeah, thank you very much. It's Buchinger, but yeah, it's hard to pronounce. In the ISO 19040 series describing the ER-Calux AS and YES procedures, it's recommended to have a sealing of the caps from PTFE, so the Teflon sealing is there recommended.
Yeah, you are right. So it is also, yes, if you have a specific cleaning of everything, it could also, PTFE is also something that could be implemented to prevent, for the caps. Yes, you are right. You can have this as we have in the vials later in the process. You are right. But yes, we recommend also to include also a cleaning alumina foil to be sure. So we are really time for discussion, so do not hesitate because if I look at the agenda, we are 30 minutes in advance. So do not hesitate if you would like to share your background experience.
One more question from Sebastian.
Yeah.
Yeah, it's perhaps just coming back to an earlier topic where you said that the discussion about the EQS is still ongoing and that share supposed quite so lower and in respect to E1 much lower EQS levels. The interlaboratory trial is scheduled for November, right?
Yeah.
And when the decision is taken later, so I just wonder, I assume that you spike samples that you distribute at EQS levels or required levels to be valid for the Water Framework Directive. But if then later the EQS levels are much lower, how does this just from the timing fits together?
Thank you for this very relevant question. So to be honest, we at this stage, we do not think that we will organize this interlaboratory comparison at this so low level. We will have really time for discussion tomorrow, but we are making a survey with all the persons we would like to join this meeting to tell us what are their actual capabilities. So we will fix the level considering the actual capabilities of the laboratories that are interested to take part to this interlaboratory comparison, to be sure that we will have a sufficient number of results to be exploited. And it is a preliminary interlaboratory comparison, and it's clear that in the near future, others will come at lowest level. But here, we are not sure that if we go at so level, we will have so many laboratories in capabilities to really perform the interlaboratory comparison. So we need to have a critical masses of results for exploitation. But I think if Paolo or Timo would like to complete what I'm saying, because this is my colleagues that are in charge of this interlaboratory comparison organization. And or we keep this question an important question. In fact, and I think we will all be pleased to discuss this specific point tomorrow because it is a critical point, still not totally fixed in the project, because we want to be sure to have sufficient participant.
Yes, yeah, we will discuss tomorrow. Yeah, I think looking also to have a view of the capabilities of the laboratories, that's really different range of LOQ from 1 nano, for example, from 1 nanogram per liter to 0.0. So it's really different, the framework.
So I really hope that you will be with us tomorrow and putting this question once again on the floor. And I think it will be very useful also for us to have this discussion with you, because we are really in it is really a hot point actually in our discussion in the project, and it's definitely not easy to take the final decision. So I really hope that you will be there tomorrow for this discussion. But it's clear that the regulation has not finalized its process, so we have to deal with that. We are we do not know what will be the final decision of the Commission, but we have to do our best to deliver with respect to our constraints in the project. And our project will end in February, and we cannot wait, especially if there's still delay in the final decision of the Commission.
Sophie, we have 2 more questions.
Yes.
One from CB. Going back to the bottle, what do you think about aluminum or steel bottle?
So we have not tested them in the project, but it's true that they are, I would say, recognized, especially in all ISO 67 guidance, as really relevant for organic pollutants measurements. So it is really, I'm not in position to make a formal recommendation because I have not tested them, but I would say that if the cleaning process are well mastered, and if you make a test to validate that you do not have significant sorption, there's no way to not to implement them. But we have not tested them in the project, so I have no real clue concerning the losses that could happen at low level. I mean, at the lowest level, those we are really under our focus. So I cannot tell more because I have no specific clue to support this. But it's clear that it is implemented in real-time monitoring, and I think it has to be tested, but in the project it was not possible to test all the different containers, so we have made some choice.
We have another question from CK. What about passive sampling of estrogen? Is there some studies about that?
Okay, so yeah, passive sampling, of course. So we have not investigated passive sampling within the project, but of course we have demonstration that passive sampling could be a solution to overpass some of the challenges because of their capability to integrate estrogen in the time. But there's different issues that should be addressed. First, passive sampling are not necessarily capable, or there's no real clue that they answer to the need, to the requirements of whole water measurements, because at this stage, I would say that the community mainly recognize that we are much more making dissolved, addressing the dissolved phase of the free form of substances and not the whole water. So this is the first point. Second point, so you have different type of passive sampler. You have studies that demonstrate the relevance of POCs for monitoring estrogens. We have calibration data, so you can expect to have this, I would say, estimation of time-weighted average concentration of estrogens in the environment. But the point is that the accumulation rate are not so important for estrogen. So if you and depending on the time you will let them in the field, perhaps the concentration factor will not be sufficient to increase significantly your capabilities to quantify these substances. So not so sure, because if you let them 15 days and if you have an accumulation rate of 0.2, you don't have so much gain in terms of sensitivity, perhaps, compared to a very good, I would say, method based on the spot sampling. Other points are experience, and I think it is shared by many of you. The main challenges is to overpass the matrix effects for estrogen, especially when you are performing LCMS measurements. And of course, when implementing passive samplers, especially POCs, you will have this accumulation of estrogen, but perhaps you will also accumulate a huge amount of organic matter in the POCs phases. So perhaps you will have faced also some important matrix effects. So perhaps the gain will not be so evident on also in terms of capabilities to have sensitivities. And last but not least, there's still the question also about the uncertainty budget and overall uncertainty delivered by, I would say, passive sampling measurements. At this stage, we do not really have studies that strictly address the different contribution of uncertainties, and especially the uncertainties linked to the calibration for those substances. So the question is, should we fit with the requirement of 50% uncertainties at the EQS? Not sure. And last point, we do not have standards. So of course, we have a standard, a general one, but it's not really technical and sufficiently precise to be implemented in lab. There's question on how to validate methods in lab implementing passive sampler approach. So there's no real accreditation schemes that are really largely available everywhere in Europe. So it is a problem to fit with the directive QAQC. So yes, many issues. So what I can say is that they have potencies. They could perhaps help. I do not know if they could really replace classical approach at the state of mastery in the development and achievements in the community. If there's other experts that would like to complete what I've said, please do not hesitate. I know that there are also experts in this area in the audience. And I hope I have answered your question at my best.
We have first Sébastien want to talk.
Yeah.
Just in addition to the question about the aluminium bottles, for the interlab trial for the effect-based methods, we used aluminium bottles and tested, of course, prior to the sending of the samples, and it was fine for the EBMs. What was not fine, so perhaps a little bit embarrassing that we didn't knew this in advance. Of course, do not put acidic samples in aluminium bottles, otherwise they start to dissolve. Yeah, but aluminium bottles in general, we said to be fine for the EBMs at least.
Yeah, okay. But you did not perform tests for estrogens in their individual form.
No, it was the sum parameter of the effect.
Okay. Thank you.
And we have a Christian.
So just a further comment on the passive sampling. I think the main issue is that we are not able to measure a distinct concentration of estrogens because we are not know the exact volume of the water sample which passes the passive sampling device.
Are there other points you would like to put on the table?
At this time, I have no more question on the chat.
So there's two options. Either we make the lunch, the coffee break now, and we start and we have a longer coffee break, or we keep only 50 minutes, but we start the next session earlier. As I would say, up to the general attendees, what you would like to prefer, to have a longer break, or we keep the break at 15 minutes and we go back at 11.
There is one comment. Can we resume at 11?
Okay. So no problem. So I suggest that we make the coffee break now, and we go back at 11. Doing so, we will finish a bit earlier, or perhaps not. If there's important discussion just after, we will have more time to discuss. So it's time for coffee break, and let's go back in at 11. Thank you all.
Thank you. See you
Fine.
later.
Thank you.
Thank you.
Thanks. See you.
Huh?
I see a comment on the chat. So yes, all the content and the information that will be delivered to you during this 3-day session will be open for the wider audience. So we will let you inform just after we'll be able to find all the content that we are sharing with you. So yes, everything will be open and accessible.
So, Sophie, do you want to present your slides first?
If you are okay,
yes,
in fact, I think
sure.
it will be an introduction to what you will present after. I have forgotten them in the first part. I apologize. So yes, if you don't mind, Christian, otherwise I will share them tomorrow.
No problem.
Thank you, Christian. So I think it's 11. So I hope that you all enjoy your coffee break and that you are prepared for this end of morning. Before to let the floor to my colleague Christian Piekota, I would like to come back to some principles that I have forgotten to share with you. Many issues. What do we need to measure? What are we measuring? It is a key starting point, in fact. So just coming back to some definition, just to be sure that we are all have the same ideas in mind when talking about some concept. So whole water. So they are defined in the guidance circa 19. So I pick up the definition there. Is synonym from the original water sample and should mean the water sample when solid matter and the liquid phase have not been separated. liquid or dissolved fraction should mean an operationally defined fraction of whole water from which suspended particulate matter has been removed by an appropriate methodology. And suspended particulate matter should mean the particulate matter fraction of the whole water sample after separation with an appropriate methodology. The total concentration of the analyte should mean the total concentration of the analyte in the whole water samples, reflecting both dissolved and particle bound concentration of the analyte. Dissolved concentration of the analyte should mean the concentration of the analyte in the liquid fraction of a whole water samples. And last, particle bound concentration of the analyte should mean the concentration of the analyte bound to SPM. It was just to remind all of you about this critical definition, and just to precise that here we are really focusing on total concentration of the analyte in whole water sample. It is really the requirement, and this is the work we have underpinned in the project. When talking about these whole water measurements, there are different ways, in fact, that could lead to whole water measurements. First, a direct analysis of water samples. Second, you can have a separation of phase. In the one side, you will analyze disolvent. In the other side, you will analyze SPM. And by a calculation, you will reconstitute the whole water measurements. And last, but it's not really a conventional way of proceed, you can have the separation of phase, the extraction, and you reconstitute a combination of both extract, and you have the final whole water measurements. And in the project, each of these approaches have advantages and disadvantages and drawbacks. And for direct analysis, it's clear that it is simple to implement, but you have limitation of intermediate steps in sample prep to minimize risks of sorption and contamination. And its drawback is that the absence of knowledge of the partitioning and the limitation on the choice of the sample prep approach. Separate analysis of both SPM and dissolved phase, you have the knowledge of the partitioning, and they are compatible with automated sample prep approach, or for many of them. You have, as drawback, you need to have sufficient quantity of SPM to make the quantification, so it could imply large volume sampling. You have an issue of the calculation, especially if you have one of the fraction where you have below LOQ measurements, so you need to comply with that. You can have loss by sorption during the filtration step, and you increase the risk of cross-contamination during the filtration and multiple sample prep approach. And last, the last option, it is compatible with automated sample prep approach. You overpass the issue of calculation, but you have the absence of knowledge of the partitioning. You could have loss by sorption during the filtration. Still some risk of cross-contamination, and you have to imply ad hoc quantification approach to have reliable measurements. So in the project, we choose the first option, so the direct analysis of whole water measurements, and all the sample prep approach that will be presented by my colleagues after are with this strategy as a prime focus. Concerning how to deal with free and conjugated estrogens measurements. So here an illustration of possible candidates. So you can have the direct analysis. And here, depending on the technique you will use, you can have the free form and the conjugated forms separated. You can also have the option, if you want to have, you have the option to separate forms. So you can have a direct analysis of the free form, and by implementing a deconjugation approach, and you can have the equivalence of conjugation in the initial sample. And you can make the third approach. You deconjugate the water samples, and then you make the analysis of the total estrogen as free one, but it's complex to be implemented. And in the project, we have really selected the first approach, and we have only focused on the free form of estrogens as requested in the European Directive, but we have addressed conjugated form just to reliable or quantification of free form of estrogen, as we have yet a little bit discussed before, but it was just to remind you the picture and what we have done. We have also, it is also important to see how it is important to consider SPM and some critical parameter of the matrix to have the minimum, I would say, level of demonstration to answer to European directive. So we have made an overview of the European water, inland waters as the more representative one. We have also lakes and groundwaters, coastal waters, and transitional waters, which are less represented. We have also here the picture of, as instance of the France, and France is a representative picture of European, just to demonstrate what we have done before. So as representative, we have made overview of French database on physicochemical characteristic of water that are routinely monitored in WFD. And here you have the picture that show you the distribution of the SPM content in the French water bodies monitored. And you can see here that the majority, and the real majority, more than 85% of natural water bodies are a very low level of SPM, below 25 milligrams per liter. And in the remaining 50%, 10% have SPM between 25 and 50, and only 4% have SPM content between 50 and 100 milligrams per liter SPM. Then you see that the average is at 21, around 21 milligrams per liter, and the median is 9 milligrams per liter. To complete, we have also made the same review on total organic carbon, and here you see that the median value is 3.1, and then the average is 3.8, and max 4.6 milligrams per liter. And the conductivity is also in the median at 381 microsiemens, and that average is close to 500, and that the pH are between 5.3 and 12.9. Just to show you how, after all the activity we will present, we have designed all the tests and make the selection to demonstrate and to optimize and validate the method we will share with you in the next coming days. It was my last overview, and now I'll let the floor to Christian to introduce more to you more in depth all the issue links to our real analytical development. I do not know if there's a question. If not, I let you the floor, Christian.
Yeah, no questions. So I think that Christian could be talk.
So thank you, Sophie, for your kind introduction and handing over to me. So from me also a warm welcome to this training workshop on the European WFD. And to support the European WFD, including their requirements, it is, I think, essential to analyze the 5 target estrogens with regard to their concentration in the environment. And here are quantification strategies for these estrogens needed. But I think, first of all, it is essential to identify the target estrogens in the chromatograms with mass spectrometric detection. And here it is necessary to demonstrate that the identification of the target analytes is properly achieved, and moreover that the target analyte signals are not influenced by the presence of chemically or physically interference, for example, matrix effects.
Christian, we don't see the presentation.
Thank you, Karine.
It works now, Christian.
Perfect.
But you are not in a full screen.
Okay, perfect. Thank you. So the target analytes, that means our 5 estrogens, shall be identified in accordance to the ISO standard 21253-1. And here we have to define target mass to charge ratios for each analyte, if possible, using a quantifier ion and at least 2 qualifier ions with distinct intensity ratios. Using tandem mass spectrometry, the implementation of transitions of the target molecules to specific fragments is important. Using high resolution mass spectrometry, the definition of specific extract mass to charge ratios for the target molecules or of specific fragments is needed. So when we have identified our 5 target estrogens, we want to quantify them. And here a common approach is the use of an external calibration. Here we can use the unlabeled target estrogens. After regression calculation of estrogens concentration by using regression equation of the areas of the sample extract obtained by LC or GCMS. The issues here are that we cannot see the loss of analyte during reconcentration or cleanup steps. Also, we cannot consider the influence of matrix on the measurement, which can cause enhancement or reduction of the signal intensity compared to non-matrix containing calibration level. So that means an internal standard is needed to correct the loss of analyte during sample preparation or sample inlet to chromatography with mass spectrometric detection. So this internal standard should be a compound that has similar chemical and physical properties with respect to the species of interest in the samples. And here I think the choice goes to the stable isotopic labeled target analytes. That means deuterated 13C or 18O labeled species. They have identical boiling points, polarities, and fragmentation patterns, for example, in electron impact mass spectrometry, compared to the target estrogens or the target analytes. And so the internal standards and analytes get the same impact by matrix, sample preparation, purification, and analysis. And a typical setup when using isotopic labeled internal standards you see above So we set up a calibration with 5 calibration levels. In each calibration level, we put in the same amount of internal standard, and we increase the concentration level of the non-labeled analyte. And in the sample, we put the same amount of internal standards we put into the calibration level. And here you see the strategy. That means we have here 10 calibration levels. It is done for estriol. And you see here the concentration of the non-labeled analyte, and you see here the concentration of the internal standard. That means the concentration of the internal standard is in each calibration level the same, and we have increasing concentration from calibration level 1 to calibration level 10. Or I'm sorry, it's the other way around here. And after that, we set up equation for a linear regression. That means we put in the ratios of the peak areas from the non-labeled compound and the internal standard over the concentration ratios. And then we do a linear regression. We get the equation, and we can solve the equation for the concentration of the non-labeled target analyte. And here are some examples for internal standards we can use within the project. So in general, certain C-labeled species are more stable than deuterated ones. Here are some keywords: deuterium-hydrogen exchange, depending on the position of the labeling. But it could be demonstrated within the project by all the project partners that deuterated estrogens are stable and can comparable be used as certain C-labeled species. And this decreases the costs, for example, for routine laboratories. And as I mentioned before, we have here some examples for 17 alpha or 17 beta estradiol. We have here the deuterated species. For estriol, we have here also the deuterated species, as well as for estron and 17 alpha ethinyl estradiol. And it is commonly called the isotope dilution mass spectrometry technique, but I think we should better call it the organic isotope dilution calibration, because the IDMS technique is established more in the analysis of elements. That means in the inorganic, for example, ICP-MS technique. And when we're using the internal standards, we have to respect some properties of the internal standard. That means we have to respect the equilibrium time of the internal standard. So in our synthetic real water matrix, we have humic substances like humic acids, and we have the suspended particulate matter. And this reduces the extraction efficiency down to 10 up to 75%. And the recovery of the internal standard is depending on the equilibrium time. To obtain a reliable estimate, it is essential to allow a certain time of equilibration between the isotope spike and the aqueous matrix. And here we have a experimental design where we tested out several equilibration times from a short time up to a long time equilibration. And we found out by all the partners in the project that we need at least 12 hours to let the internal standard interact with the water matrix to have a constant concentration of the internal standard in the sample. And in consequence, the sample must be spiked with the isotopically labeled standards at the end of the working day, for example, to store the spiked water samples overnight for at least 12 hours at +4 degrees Celsius in the fridge. So within a typical method validation, the method recovery, for example, the absolute and relative recovery will be assessed to see the performance of the capability of the analytical procedure. And the absolute recovery will be determined in each matrix by comparing the peak areas of spiked samples prior and post-extraction. And the relative recoveries will be calculated in each matrix by comparing the ratios of the peak areas of the target analytes to the corresponding peak areas of the internal standards in spiked samples prior extraction and post-extraction. And compared to the isotopic labeled calibration strategy, there are other alternative quantification strategies. For example, the standard edition. It is a type of quantitative analysis approach added directly to the sample. It is used where the sample matrix also contributes to the analytical signal, a situation known as a matrix effect, thus making it impossible to compare the analytical signals between sample and standard using the traditional calibration curve approach. And also it is possible to use a non-isotopic labeled standards. Here for the estrogens, we can use structural analogous compounds, for example, 3-O-methyl-estron. So in conclusion, analyzing estrogens in complex water matrix, suitable internal standards are needed to respect matrix effects and the loss of analytes during sample preparation, and some further purification steps. A stable isotopically labeled species of the target analytes should be used. And in consequence, it is the organic isotope dilution calibration with mass spectrometric detection, which is a powerful tool to increase the relative recovery of the target analytes within the analytical procedure. And here I ask you for further comments, questions, or concerns what I have said in the last 10 minutes.
Christian, I have one question. When you use direct injection, do you inject directly samples into the instrument without filtration? Without filtration, do you have a problem such as overpressure of column?
So when we are doing analysis with regards to the European Water Framework Directive, we want to analyze the whole water, and the whole water contains also, as Sophie mentioned before, SPM, that means suspended particulate matter. And when we are thinking about, for example, HPLC or UHPLC, and when we inject samples with particles, it can clog the whole HPLC system. So that means when we want to analyze the samples, we have first to filtrate the samples, investigate the particles for the estrogen concentration themselves, and determine the estrogen concentration in the water sample without SPM. So I hope this question was answered.
we have no new question, so maybe you could continue on the next stop.
So, do you listen me? So, do you listen me?
Yes, you could talk.
Okay, I'm Salvatore Barreca. But by direct injection, it's possible to consider this procedure for to analysis for water sample, or it's not totally correct? Only this question.
To our point of view, this is not fully answering the question of whole water measurements. And in any case, the knowledge gained by the project is that with direct injection, you could not reach the required level of performance in terms of LOQ. So we failed with this strategy. It has been investigating, and perhaps if you don't mind, perhaps we can let prep and injection has been included in this presentation, and perhaps we can go back to your question after this talk on sample prep, if you don't mind.
So cool. Then I will go on with the next presentation. If there's no other comment or question.
So there is just one question about the volume injection with direct injection.
So we tried the direct injection with different injection volumes going up to 100 microliters, starting at 10 microliters, and with samples without SPM, it works, but not on the levels of the EQS given by the European Water Framework Directive. It is not possible to investigate or to quantify the estrogens by direct injection. That is not possible.
Okay, I have no more question.
Okay, so then I go on with the next presentation. So before quantifying the estrogens in the water samples, I think we have to do sample preparation. And in the next 30 minutes, I show you some strategies we investigated with regards to the sample preparation and the purification of sample extracts. And in general, it's a compromise is necessary, which addresses the whole water sample, a reasonable pre-concentration factor, and the robustness of the method. So the pre-concentration is necessary because of the low EQS given by the European FWD, sorry, for the target analytes, and the separation of the matrix compounds from the target analytes is also necessary to prevent matrix effects on the chromatographic separation. Here, for example, the decreasing separation efficiency of the chromatographic column, the enhancing or decreasing of the signal intensity, for example, if you know the effects of ion suppression in the EZ source, and to avoid contamination of sample inlets, especially when you're using GC. Here you can contaminate the GC liner by matrix components. So within the project, we pre-select some feasible and applicable techniques by all the project partners due to their practical knowledge. And the results of the pre-selection done by all the project partners was that we follow 4 different strategies for a pre-concentration procedure. First is common use liquid-liquid extraction, typical solid phase extraction off or online. We tried the so-called SPE discs, and we investigated new procedure, the MISPE, which means the molecular imprinted polymer solid phase extraction. And first we tried the liquid-liquid extraction. Here it is necessary to use a high volume of organic extraction solvent, typically 30 to 50 milliliters. And in the consensus of green chemistry, you use a lot of organic solvents. So also we can use only non-miscible organic solvents for the extraction. That means we have a limited selectivity, and only batch extraction is possible. That means we have to repeat it with new portions of fresh extraction solvent. Moreover, it is, I think, physical stressful for who do the extractions. It is not automatable. You can do no extractions in parallel, and this means it is not feasible for routine laboratories and also not applicable in routine labs. But we tried it, and we used a 500 milliliter water sample, do 3 extractions with 30 milliliters of dichloromethane. The extraction time was 1 minute. We combined the organic layers. The evaporation of the organic solvent was done up to dryness. We reconstitute it with 1 milliliter acetonitrile, and this extract we directly analyzed by LCMS. And here you see the results. We have sufficient absolute recoveries for E1, E2, alpha E2, and EE2, but we have very poor absolute recoveries for E3 independently from the type of water matrix. That means low complex water matrix, but also high complex water matrix. So we did these experiments in molecule water. That means low complex water matrix, and we do it in Evian water. It's moderate high complex water matrix, and here we have for estrogens sufficient recoveries, but for E3 it doesn't fit. So going to the solid phase extraction, here we can use the off or online version. Here we have different selectivities in terms of the sorbent material. So we can use common used C18 sorbent material, or end-capped C18 material, as well as also the very well-known HLB material that stands for hydrophilic, lipophilic, balanced solid phase extraction. And here we have the effects that we can use this SPM technique with less than 50 milligrams per liter of SPM, and we can observe no clogging of the cartridges. But when we have higher amounts of SPM, the SPM cartridges clogged, and we are not able to do the pre-concentration. Another problem is that when we do the pre-concentration with this sorbent material, we not only pre-concentrate the target analytes, but we also enrich, for example, the DOC content. And this was evaluated by measuring the DOC in the sample extract. And it is up to 70% of the initial DOC we found in the sample extract after extraction. And this causes the so-called ion suppression in the easy source when we are doing LC-MS. And in most cases, the signal intensity decreases. It's a very well-known effect in the easy source. So here is a typical procedure for solid phase extraction. We can use 1 liter of water sample. We can spike it with the internal standard at the desired level. We have to respect the equilibrium time. That means we have to allow to stand the water sample for at least 12 hours at +4 degrees in the fridge. After that, we can do the extraction. Here we are using HLB in a 3 milliliter cartridge with 100 milligrams of sorbent material. Then the SPE cartridge with acetonitrile and then with water. Then we can load the water sample, for example, with a flow rate of 20 milliliters per minute. After that, we have a washing step and an elution step. And here we are collecting 10 milliliters of acetonitrile. And this extract can be concentrated to 1 milliliter using, for example, a TurboWeb machine. And this extract is then ready for analysis by LC-MS, MS, or GC-MS. So all the experiments were carried out by all project partners. We are using different matrix compositions. For example, the low complex matrix, which consists of Evian water with low DOC and without SPM. And we are using a high complex water matrix, which consists of Evian water and a moderate DOC with suspended particulate matter. And we are determine the relative and absolute recovery rates to compare the different experiments with regard to their performance. That means, in routine laboratory. And here are some results. So here for a low complex matrix, that means Evian water and DOC content of 7 milligrams per liter and an estrogen level at 5 nanograms per liter. And we have sufficient absolute recoveries for all the 5 estrogens. And also very sufficient relative recoveries when we are doing the isotope dilution calibration. But we have no SPM in the water matrix, which can cause clogging of the cartridge. Going to high complex matrix, consists of Evian water with a moderate DOC of 7 and 50 milligrams of SPM. As I told you before, this is the maximum of SPM content we can use for SPE cartridges. We have sufficient recoveries for all the 5 estrogens. But as I told you before, the matrix will also be pre-concentrated, and this means we have increasing signals by diluting the sample extracts. And then we have ideal relative recoveries by isotope dilution calibration. So to use more SPM content in water samples, we found a good compromise, and this good compromise is the use of SPE discs. And here we have filtration and enrichment step in one procedure. Here we have also different selectivities like HLB, C18, or DVB. We have different capacities of the sorbent materials, but we need a special manifold which is suitable for the SPE discs. We have sufficient recoveries, and it is also applicable for water samples with a higher content of SPM, for example, for 500 milligrams per liter water. But the pre-concentration of DOC content is comparable to the common SPE experiments. This is a typical procedure for applying the SPE discs. We first spike our water sample with the internal standards, have to respect the equilibrium time. Then we have to condition the speed disk as well as the SPE cartridge, also with, for example, here acetonitrile and then water. And then we can load the water sample over the SPE disk. And here a main advantage is the loading time of the water sample. And it takes only about 30 minutes for loading 1 liter of water over this SPE disk. After that loading step, we wash the cartridge as well, and we can elute the speed disk with 5 portions of 10 milliliters of acetonitrile. We can concentrate the organic fraction to 1 milliliter, and this yellowish extract is ready for analysis by LC-MS or GC-MS. And again, the experiments were carried out by all the project partners. We use here only the high complex water matrix, which consists of warm water, DOC, and SPM, and we determine also the relative and absolute recovery rates. Oh, so I'm sorry, here we have an example which is low complex water matrix, which consists only of evian water and DOC. Here you see we have sufficient absolute recoveries and also sufficient relative recoveries by isotope dilution calibration. So this experiment was done using 1 liter of evian water and spiking this evian water with 7 nanograms per liter of each estrogen. Here we have high complex water matrix, which consists also of SPM. And also here we have sufficient absolute recoveries as well as sufficient relative recoveries, which are quite nice. There's another example. Here we have a different selectivity compared to the example before. Here we are using a DVB selectivity, and here we have a C18 discs, and we used also spiked unfiltered surface water, not the evian water. And here we have not so nice absolute recoveries. They are not sufficient, but we have ideal relative recoveries by isotope dilution calibration. And the last possibility we checked was the molecular imprinted polymer solid phase extraction. And here we get a distinct protocol for the purification from the supplier. And this allows us only to use 100 milliliter of water sample. And I think due to the EQS levels given by the European Water Framework Directive, this is not suitable for estrogens. But the advantage of this technique is the specific pre-concentration of estrogens because of the key lock mode of action. So I think this could be an ideal procedure to separate matrix compounds, for example, DOC or other inorganics or whatever, from a sample extract. So a possible implementation as a further purification procedure of extracts can be obtained from pre-concentration steps. So we tried to use the molecular imprinted polymer solid phase extraction with 1 liter of water sample. And here we have moderate relative recoveries compared to the common SPE. So when we conclude all the results, as we discussed before, the direct injection is not applicable for this kind of analysis, but the SPE in off or online mode, the SPE desk, the liquid extraction is not applicable, but the molecular imprinted polymer SPE could be applied as a purification step for extract. So focusing only on the solid phase extraction techniques, SPE is applicable for whole water samples with a SPM load less than 50 milligrams per liter to avoid clogging of the cartridges. For higher SPE load, the SPE disk is favored from all project partners as a method of choice. So when we are thinking about a purification of the extract coming from the pre-concentration, it is possible to use the molecular imprinted polymers. And we tried this. Here we have an extract from the pre-concentration step, and we can dilute this extract with 100 milliliters of water sample. The volume is compatible to the max volume given by the provider SOP. And as I mentioned before, the advantage is a specific pre-concentration because of the key lock mode of action. And another possibility is to use some other SPE cartridges for purification of sample extracts within the project. The LC-NH2 SPE was evaluated, and this is a silica gel-based material with amino bonding functional groups. This increases matrix components, but is not so specific as the molecular imprinted polymer SPE. There are also mixed phase cartridges available containing, for example, C18 and aminopropyl functionality. But due to the limited capacity, it is not sufficient as a two-step procedure. And this is a typical procedure for the LC-NH2 cartridge. We have to condition it with 4 milliliters of methanol, load the sample extract, then we elute it with 2 milliliters of methanol. We concentrate the organic fractions to a desired volume, and this clear extract is then ready for analysis by LCMS or GCMS. So the first conclusion, there are appropriate techniques either for pre-concentration or for purification of the extracts, and these could be evaluated and established within the project by all the partners. Using, for example, the HLB sorbent material for SPE or SPE disc, the DOC will be pre-concentrated, and only 50 to 70% of the initial DOC can be removed by the pre-concentration procedure. As I mentioned before, this can interfere the analytical procedure. For example, in case of LCEZ-MS, ion suppression can occur. And the result of this ion suppression is the loss of sensitivity. So a further purification of the extract from the pre-concentration procedure is recommended by the project consortium. And so after that, we carried out some different two-step procedures for pre-concentration and purification. And these experiments also were carried out by all the project partners. We used only a high complex matrix, which consists of evian water, DOC, and SPM, and we determined the relative and absolute recovery rates to make the experiments. And we have an experiment where we use SPE and for pre-concentration and the LCNH2 SPE for purification. And here you see the absolute recoveries are quite nice for the internal standards in the range of 74 up to 83%. And the relative recoveries by using the internal standards, we had quite nice recovery rates ranging from 89% up to 116%. And in this experiment, SPE disk was used for pre-concentration and also for purification. LCNH2 SPE purification was applied. And here we did different experiments with a different complexity of the matrix. Here we have evian water with SPM, evian water with DOC only, and here the high complex matrix, which consists of evian water, DOC, and SPM. And here you see in the first table the absolute recoveries, which are also quite nice, but when applying the isotope labeled internal standards, we have much better recoveries, especially here for evian water and SPM. And the last example I can show you is the combination of the SPE disk with the molecular imprinted polymer SPE. And you see here on the left side the water sample, and in picture B, the extract coming from the SPE disk, which is very dirty and very yellowish. And we did the purification step here in picture E with the MIP cartridges. And you see in picture H on the left side, the complete clear extract coming from the SPE disk ME SPE experiment. And we measured the DOC content in the extract, and it's less than 1% of the initial DOC content in the water sample. And here you see some relative recoveries for a complex water matrix. 1 liter of evian water, 7 milligrams of DOC, and 50 milligrams of SPM. And this water sample was spiked with estrogens at a level of 0.1 nanogram per liter. And here you see the recovery coming from the SPE disk, the recovery coming only from the MIP SPE. And here you see on the right side the recoveries from the combined procedure. That means combining HLB SPE disk with ME SPE. And they are quite nice. So the recoveries are in all cases very good, but the absolute recoveries were much better in the combined procedure because we have less matrix in the extract. That means we have no ion suppression in the ESI source, and this decreases, this increases the signal intensity. And another issue which was discussed in the morning, that we have conjugates of estrogens in whole water samples. So when we have estrogens present in the body, we have a kind of phase 2 metabolism of these estrogens, and this is leading to conjugated species. And these conjugated species are very soluble in water and can be excreted. And then we have these conjugates of the target estrogens in water. And here we have the question if the conjugates can be reconverted back to the estrogens as a kind of a circulating reservoir for estrogens. Yes, you see an example for E2, and as Sophie mentioned before, the residue for the conjugation are, for example, a glucuronic acid molecule you see here, and there are other types of conjugation possibilities, for example, sulfates, phosphate, glycine, and so on. And what is to be known is the influence of sampling, sample storage, and sample preparation on the conjugate stability. That means when we have conjugates present in the whole water sample, what does our sample preparation do with these conjugates? Are they destroying them, or are they stable within the whole procedure? And there's a possibility that you can separate the conjugates from the free estrogens with a common used SPE procedure. You can use the Oasis HLB as well. And then you separate the conjugated forms from the free estrogens. And then you can separate the conjugated forms. You can deconjugate them by acidic hybridization, for example, and then you can determine the deconjugated free estrogens with LCMS or GCMS, and on the other hand, you can investigate and quantify the free estrogens from the water sample. But it takes a lot of effort and work to do this, and so as I mentioned, we have to investigate the sampling, the sample preparation, and the analysis step, and see how it influences the conjugated forms of the estrogens. And we choose 3 model conjugates. You see here in the table the 17-beta estradiol glucuronide substituted on different positions in the molecule. Here on the aromatic ring, on the phenol group, and here on the hydroxyl function in the backbone of the molecule. And we have here a double conjugated estrogen, which is conjugated here on the phenol group with a glucuronide, and on the hydroxyl group with a sulfate. And we did our sample preparation, pre-concentration, the purification, and so on. And then we investigated the water sample for free estrogens. And you see here, we spiked the conjugates at different concentration levels, for example, 10 nanograms per liter, 20 nanograms per liter, 100 nanograms per liter, and 200 nanograms per liter, and we determined the free estrogen concentration. And as a consequence of this experiment, the effect of deconjugation could be observed during storage and sample preparation, but calculated on the average molar mass of these three conjugates, approximately 0.16% of the used model conjugates were deconjugated during the whole analytical procedure. And I think this low amount of deconjugation could be handled by the uncertainty of the analytical procedure. So that's all from my side. Have you questions, comments, or remarks on my procedures and my proceedings?
Christian, I have one question about SPDISC. Did you use SPE desk, and which type of SPDISC did you use? L, aim of H, about the size of SPDISC.
So to be sure that we handle all the matrix, we use the high capacity of speed disk.
And did you use SPE desk?
I'm sorry, I did not understand your question.
Did you use SPE desk automatically?
No. We are using only manual SPE disk.
If I may jump in, between the different partners, some use SPEDEX, others use classical approach, but we have both approach in the project.
At this time, I have no more question. Someone want to talk? Sebastian?
Yeah, thank you. A lot of work, really impressive. All this testing of the extraction and purification. I had a look at the document where the ILS was announced, and perhaps this is something we come back to on Friday, talking about the EBMs. I don't know if you know which document I'm talking about, and there it is written that the pre-treatment and purification step for the EBM is as well mandatory. And I just wonder if you have tested this in comparison, because for the EBMs you have, of course, a very specific you can very specifically distinguish, let's say, random DOC from the specific molecules you want to detect because of the specificity to the reporter, to the receptor. So the question is, do you have all this what you have done for the MS analysis? Have you done this as well for the EBMs?
So we did the pre-concentration procedure combined with the purification step as well for the EBM methods, but we have not measured the extracts yet. But we are sure that it is a main advantage of this two-step procedure, because we can separate the humic substances, for example, from the water sample, which can cause us cross-reactivity to the EBM in terms of estrogenic activity, for example.
Yeah, So we use EBM here at the Federal Institute of Hydrology. I have to admit, we never really, so we did one purification step once, but that was done with silica, and there the observation was that the estriol was lost. But of course, this cleanup step was not really perhaps optimized to have a full recovery of the estriol. So my tendency for the EBM would be not to do too much purification, because you want to measure an overall estrogenic activity. But yeah, if we participate, then we have to include a cleanup step. Do I understand this correct? Right?
Yeah. So here you are once again coming back to the interlaboratory comparison we are planning to organize. And I once again suggest that we discuss this point tomorrow, but yes, just to have information, estriol is definitively a very specific one compared to the four others. We all have bad experience with estriol when implementing at first stage or purification step. We have lost the substances. It's really, you really need to have specific solvent to keep it until the end. And just to complete, it's clear that silicium or fluorosil purification approaches have not been tested within the project, because as you have seen, we have at some moment been obliged to make some choices. We cannot test everything, but it's clear that they are also relevant. It's not our message. We are communicating to you about what we have done, and it is why we really expect some feedback from others. And I know, because we are working with German colleagues that will also make a lot of work in developing methods for estrogen, that fluorosil and silica could be also relevant, but you have to take specific care with the solvent you will use to keep estriol until the end of the protocol. And concerning the requirements to participate to the interlaboratory comparison, I suggest that we switch the discussion to tomorrow and Friday, because we will address the issue on both sessions, to have all the questions around that on the same time. And doing so, I'm sure you will be back tomorrow. It's strategic, in fact.
Yeah, thank you.
You will all stay with us until the end of the week. So if there's no other question, I think that it's time to close this first session, and it's also time for lunch break for many of us. I would like to thank you all for being there with us, for the nice question and discussion. We really hope that you enjoy this first session and you learn new things around the estrogen measurements. And we go back tomorrow morning at 9 for discussion around MS-based method and on validation and first set of recommendation and conclusion. And we will, of course, discuss about the next step, and the next step is the standardization process and the interlaboratory comparison. So
thank you, Sophie. Thank you very much. See you tomorrow.
See you all tomorrow. And
Thank you, Sophie.
If you have questions, do not hesitate to contact the organizing committee, and have a nice day. Bye-bye.
Thank you.
Goodbye.
Thank you all. Bye-bye.